We're going to get started here on, what is this, RT3 lesson 2. It says part 1. We'll see if we can jam some stuff together here, so we just do one lesson 2. We're going to use inverse trig ratios to find the measure of an angle and determine when it's appropriate to use right triangle trig or inverse trig ratios. So let's get started. Okay, so sin x and inverse sin x, we had a little introduction to this yesterday. They're related on your calculator, right? On your calculator, there's a button that says sine. This is not sin, this is sine. And then right above it, it says inverse sine, right? So this right here, excuse me, listen please. This piece right here, written in black. Okay, so what this button right here will do is we will plug an angle into this, right? We'll plug an angle, theta, or whatever the measure is. That's an angle. Not an ankle, an angle. And what comes out of that, what's spit out of that? Some ratio, right? Some number, some ratio. If I do the inverse sine of some ratio, what gets spit out? What's spit out? So here I inputted an angle, I got out a ratio. Here I input a ratio, what do I get out? An angle. These are called inverses. These are called inverses. So let me show you an example of that. Sine of 30 degrees. You may or may not know this. I'm a nerd, so I know it. Is 1/2. Okay. What is the inverse sine of 1/2? 30 degrees. So an inverse gives you an angle. A normal trig function, not an inverse, gives you some kind of ratio. So it helps us to find either an angle or a side in a triangle. So basically what this is saying down here is the inverse trig function undoes the trig function. It's the inverse operation. It's like what division is to multiplication. It undoes that. Okay, we're going to go through a couple of examples on that in a moment. Okay, so if we want to find the measure of angle B, let's first set up some kind of trig function. Okay, so what would 4 be? Opposite, adjacent, or hypotenuse to B? Adjacent. Good. I'm already thinking either tangent or cosine. Sine is out, right? Because sine doesn't have an A in it. Okay, I see hypotenuse here. That tells me cosine. I sure will. Hold on one second. So the cosine of B is equal to 4/5. Do you agree? Yeah? Okay, cosine of B is 4/5. This is just an angle measure. We're going to figure out what it is. B is going to equal the inverse cosine of 4/5. Take out your calculator, please. Choo-choo. 36.86, okay, or 87. It doesn't have any rounding requirements, so I'd be okay with that. That's the measure of angle B. That's the measure of angle B. How about that with a neighbor? Find the measure of angle O. Yeah, go. Hey, let's come together and look at these two problems here. This is from angle O, this is the adjacent side. This is the opposite side. So at this point, I know I want to use tangent, right, because of TOA. So opposite and adjacent would be TOA. So the tangent of angle O, whoops, that should be an O, not a theta. Tangent of angle O would equal 5/12. So the measure of angle O is going to be the inverse tangent of 5/12. What did we get there? 22.6. Okay, anybody disagree with that? Okay, solid there, good. Just out of curiosity, how could I find the measure of OG, this length right here? Pythagorean theorem, right? 5 squared plus 12 squared you might recognize as a Pythagorean triple with 13. So you could use Pythagorean theorem there to find the measure of OG. The measure of angle S. Okay, again, here's S. This is the adjacent side. Here's the hypotenuse. That tells me which of my trig functions have an A and an H. cosine. So the cosine of angle S is equal to 4 over 10. You're going to get the hang of this because by repetition, you're going to be like, oh my gosh, I just did this. Yeah, you're going to do it over and over again, and it's going to become second nature. What is that angle? 66.42 degrees. Oh, okay. Anybody disagree? Okay, cool. That's how you find an angle measure in a right triangle using trig, inverse trig. Okay, let's see what else we've got here. Okay, find the measure of angles A and B and the lengths of the missing sides. This is called solving a triangle, finding all missing sides, all missing lengths. So all that I know is this. I know that the cosine of A equals that, and I know that this length is 7. So I've got two sides to find, I got two angles to find. Okay, so let's find angle A first. So if I know that the cosine of A equals 0.9397, oops, let's erase that, 0.9397. How do I find the measure of angle A? Yeah, just that, inverse of 0.9397. Somebody hammer that out for me. Tell me what I get. Nick? 20.446. Does that sound? Okay. Most people are getting 19.99. I'm going to go with 20 degrees. You'll probably end up rounding to the nearest whole number on the test. Okay, so if this angle right here is 20 degrees, and this angle right here is 90, what do the three of these angles have to add up to? 180. So these two are 110. That makes angle B 70. All right, so we're almost done. All right, we're almost done. We found angle A, we found angle B. Okay, now what we're going to do is we're going to use the trig that we know how to use to find one of these two missing sides. Anybody partial to BC or the hypotenuse? BC? Okay, let's call this length right here, Nick. We're going to call this length X. Ooh, we can call it N. Yeah, I guess you're Nick. We can call it N. Do you want lowercase n or upper? Okay, uppercase N. This length right here we're going to call N. Do you like 70 or 20 better, Nick? Nick likes 20 better. Okay, so we're going to call this our angle that we're going to reference. It's 20. What would N be in accordance to 20? Opposite, adjacent, or hypotenuse? Okay, so that'd be our opposite side. Okay, what would 7 be? Adjacent. Okay, so if I have opposite and adjacent, that tells me tangents. Okay, the tangent of 20 gives me opposite over adjacent. Okay, so we're going to take 7 times the tangent of 20, and that'll give us N. 7 times the tangent of 20. Are you getting 2.55? Okay, cool. So I got 2.55. All right, so that gives me a little bit more information. Nick, we're here now. We know we're going to erase this and just place that 2.55 there. What are my options for finding the hypotenuse? Let's call it C. I could use one of two things, either right triangle trig or Pythagorean theorem. Okay, so I'm going to find C by using Pythagorean theorem. Let me sketch my triangle again. Here's C. Here's 7. Here's 2.55. So C squared will equal 2.55 squared plus 7 squared. So C will equal the square root of whatever that comes out to be. Let's figure out what that is. So I get 55.5025. I'm going to take the square root of that. And it looks like I get C is approximately 7.45. So what does it mean to solve a triangle? This is what it means. I started with this. All I knew was that was 7. I used right triangle trig to help me see that this was 20 degrees, this was 70 degrees, this was 2.55, and this was 7.45. That makes sense with my hypotenuse since it's greater than both of those two lengths. Right. Okay. Okay, so What was the difference between inverse sine and regular sine? What does inverse sine come out to give you? Some angle. Some angle in degrees, right? Our normal sine comes out to give us some kind of decimal or ratio, either decimal or ratio, right? So if we're looking for an angle, we use inverse. If we're looking for some kind of ratio or side length, then we use regular sine or cosine or tangent. So would this be, example 1, would this be inverse sine or regular sine, cosine, or tangent? Yeah, this would be inverse, right? We're trying to find an angle. How about this one? Yeah, regular, normal sine, right? So we would not use inverse. This would be normal. I'm going to call it normal for a moment. Normal trig, right? Because we're trying to find a side. Inverse. How about the next one? Normal, yeah, normal. We're just using regular trig to find a side. How about this? Inverse, we're trying to find an angle. Here, normal, we're trying to find a side. That's how you know the difference. Now, you're not always going to use sine. You might have to use cosine or tangent, but that'll tell you whether or not you're going to use inverse trig or normal trig. Like, subscribe, comment below. $11 GNC gift card to the 100 sub. Have a great day. Good weekend. Gains. Snow. Life.